Hello everyone, welcome back to my channel. In the field of organic chemistry, we mainly focus on reactions, reactivity, groups, atoms, in particularly carbon, hydrogen and heteroatoms. But the main motto of learning organic chemistry is to understand the characteristic properties and characteristic propertial changes of organic compounds with variation in any one atom or any one group present in a compound, and that actually influences the whole and soul physical as well as chemical properties of a material, in a strictly speaking way, organic compound. So just now I said a group or an atom or group of atoms that is whole and solely responsible for the physical as well as chemical properties of an organic compound will be simply called as functional group. So we can call a functional group as an atom or a group which whole and solely influences, which is whole and solely responsible for both physical as well as chemical properties of an organic compound. That is a simplest meaning what we can give for a functional group. So we are having so many functional groups in the field of organic chemistry. So for example, CHO. If the functional group is CHO, we used to call that organic compound as aldehyde. Suppose if you are having this carbonyl group alone on either of the side, if you are having alkyl or aryl group, we will be calling that material as ketone. If the functional group is COOH, we used to call that material as carboxylic acid. So in this way, we are having greater number of functional groups in the field of organic chemistry. So one such functional group is OH. We call this as hydroxyl group. The OH group is called hydroxyl group. So if you go with organic chemistry, in particularly the hydrocarbons, we used to get two important kinds of hydrocarbons, namely aliphatic hydrocarbons and aromatic hydrocarbons. Suppose if in a aliphatic hydrocarbon one hydrogen atom is replaced by a hydroxyl group, we will get a derivative wherein instead of hydrogen atom at any one place, there will be a OH. That means we can call the material as hydroxy derivative of aliphatic hydrocarbons. I repeat, if one hydrogen atom of an aliphatic hydrocarbon is replaced with OH group, the derivative what we will get, that derivative will be called as alcohol. In a similar way, if consider an aromatic hydrocarbon, that means benzene. So we know the molecular formula of benzene, that is C6H6, which is having a ring structure with the three alternate single and double bond, and at each place we will be having a hydrogen. So as a total, we are having 6 hydrogen atoms on the benzene ring, one hydrogen atom at each position. That's why we are writing the molecular formula for benzene as C6H6. Suppose if either 1 or 2 or 3, depends, if one or more than one hydrogen atom of this aromatic hydrocarbon is replaced with OH group, the derivative what we will get are simply the hydroxy derivative of aromatic hydrocarbon, in particularly speaking benzene, are simply called as phenols. So phenols are simply defined as the hydroxy derivatives of aromatic hydrocarbons, wherein one or more than one hydrogen atom of the aromatic ring is replaced with hydroxyl group. So that is the simplest way of explaining the term phenols and now in this session we shall give a brief explanation regarding phenols, as well we shall look over into the detailed classification of phenols. Fine. So as we said, phenols are the hydroxy derivatives of aromatic hydrocarbons. That means in benzene we are having 6 hydrogen atoms, that is each 1 hydrogen atom each at each carbon atom. So totally we are having 6 replaceable hydrogens in benzene ring. So depending upon the number of hydrogen atoms on the benzene ring that are replaced by hydroxyl group, phenols can be broadly classified into 3 categories, namely monohydric phenols, wherein 1 hydrogen atom on the benzene is replaced with OH group. Secondly, dihydric phenol, wherein the 2 hydrogen atoms of the benzene have been replaced with hydroxyl group. And finally, it is trihydric phenol, in which the 3 hydrogen atoms on the benzene ring were replaced with hydroxyl groups. And now we shall see the details about monohydric, dihydric and trihydric phenols. So if you come to the case of classification of phenols, as we said, there are 3 types: monohydric, dihydric and trihydric phenols. So firstly we shall consider monohydric phenol. So the name itself telling you monohydric phenols. That means these are the phenols which are obtained by replacing 1 hydrogen atom on the benzene ring by 1 OH group. So we can say they are monohydroxy derivatives of aromatic hydrocarbons. Monohydroxy derivatives of aromatic hydrocarbons. Now we shall give some simple examples for monohydric phenols. So firstly, 1 hydrogen atom of the benzene is replaced with OH group. That means simply the phenol, or you can also call it as hydroxy benzene. And another example wherein 1 hydrogen will be replaced OH, but here another hydrogen atom is replaced with methyl group. So here along with OH group we are having methyl group. If benzene ring is attached with 1 OH group and 1 methyl group, we call that material as cresol. And since for methyl group OH is at the ortho position, so we used to call this as orthocresol. So similarly we can take metacresol as well as paracresol also. Shall write the structures of all those two. So OH, and here it will be CH3, and for CH3 OH group is at meta position. This is the first position, this is ortho and this is meta. So it is metacresol. And finally the cresol, in which the occupation of the group is at para position. So OH and CH3. So with respect to CH3, OH is at para position. So this is paracresol. So these are some simple examples that we can give for monohydric phenols. Now we shall go with the next category, next classification of the phenols. Okay, the second classification of phenols depending upon the number of hydrogen atoms of the benzene replaced with OH group is dihydric phenol. Once again the name itself telling you these are the phenols in which 2 hydrogen atoms on the benzene ring were replaced with hydroxy group. So we can simply say these are the dihydroxy derivatives of aromatic hydrocarbons. So here we said for monohydric phenols, that is they are the monohydroxy derivatives of aromatic hydrocarbons. Similarly for dihydroxy phenols or dihydric phenols, we can say they are the dihydroxy derivatives of aromatic hydrocarbons. That means there will be 2 OH groups on the benzene ring. Now we shall give some examples for dihydric phenols. So here I have given 3 examples for dihydric phenol. You can notice over here, in all the 3 cases we are having 2 hydroxy groups on the benzene ring. If we come to the first case, here the hydroxy groups are present at first and second position. So we can call them as 1,2 dihydroxybenzene. This is 1,2 dihydroxybenzene, or in common language we call this as catechol. And here in the second example, the hydroxy groups are present at 1, this is 2, and this is third position. So in IUPAC system we can call this as 1,3 dihydroxybenzene. It is in common name we call this as resorcinol. And in the third example, the hydroxy groups are present at 1, 2, 3, fourth position. So this is benzene or else 1,4 dihydroxybenzene. And you can notice this is in so resemblance with quinone. But in quinone we will be having double bond at these positions through which the oxygen atom will be bonded. But here there is only one bond, and along with oxygen we are having hydrogen. So that this is the other form of quinone wherein 2 hydrogen atoms are having, and is called as hydroquinone. This is called hydroquinone. So these are the 3 simple examples we can give for dihydric phenols. Okay, now let us go with the last type of phenols is trihydric phenols. That means here these phenols will be obtained by replacing 3 hydrogen atoms on the benzene ring with hydroxyl groups. So we can simply say trihydric phenols are the trihydroxy derivatives of aromatic hydrocarbons. So monohydric phenols are the monohydroxy derivatives, dihydric phenols are the dihydroxy derivatives, and trihydric phenols are the trihydroxy derivatives of aromatic hydrocarbons. And now we shall give some simple examples for trihydric phenols. Okay, here I gave 2 examples for trihydric phenols, and in the first example you can notice the OH groups are present at 1, 2 and third position. So in IUPAC system we can say as 1, 2, 3. Totally there are 3 hydroxy group. So it is trihydroxybenzene. This is the IUPAC name of this material, but in common system we call this material as pyrogalol. In common system we call this as pyrogalol. And if you come to the second case, you can notice the OH groups are present at first, third and fifth position. So that in IUPAC system we should call it as 1, 3, 5 trihydroxybenzene. This is the IUPAC name of this material, but in common system we call this material as fluoroglucinol. That is the common name. And here I gave the complete classification of phenols depending upon the number of hydrogen atoms of the benzene ring that are replaced with hydroxy groups as monohydric phenol, dihydric phenol and trihydric phenols. And this is the detailed classification of phenols.